dear student, whatever category you find yourself, just take it like that. You once again welcome to the statistics class. And just like as I promised in the previous video, that we are going to continue, or we are going to start with t-test. Of course, like I told us in the previous video, that we have been looking at the test of difference. And under the test of difference, we have looked at chi-square. That was in our previous video. And tonight, we want to quickly look at how to use t-test to run test of difference. Of course, like I told you, they are basically different tools to perform test of difference. One of it is the t-test, one of them is chi-square, and the other one is analysis of variance, ANOVA. So, but we have looked into the chi-square. If you are just joining us for the first time, or you are coming across this video online, you can check this channel for all the videos that are related to test of difference. And of course, this time around, we are looking at t-test. So when we look at it from this angle, please don't forget, if this is your first time on this channel, please, it will be better, or it will do you good if you subscribe to the channel, so that you get a notification anytime we have a video that can assist you as a student of statistics. So we want to look into t-test. Of course, when we are talking about the t-test, the name t-test, sometimes you may be looking at it that, what does it mean? What is the genesis of t-test? Of course, like I told us, is one of the tools to test, to carry out test of difference, or anytime you are looking at test of significance. So t-test is one of the tools that we normally use. Of course, like normally people do call, when you have a categories of variable that has to do with like gender, that has to do with something that has to do with tools, like gender. When we look at what other things can we look at? If you are looking at public and then private, something like that, you have to make use of t-test. So t-test is a test for two sample means. It's a test for two sample means. You need to have that one at the back of your mind. Anytime you are testing for any two sample means, like male and female, you have to make use of t-test. But if it is more than two, you will need to use analysis of variance, that is ANOVA. So, but if it is just two, you need to make use of t-test, because I can see some people who are asking if they want to make use of SPSS. By the time we get into the level where we'll be using statistical package for social science, we'll also be looking into this, that when you are doing a kind of when you are doing a test for two sample means, you need to make use of t-test. So we consider the PS of the sample under various circumstances, because there are different types of t-test. So it now depends on the sample you want to use. Those are those things that will determine what you want. Like the one you are seeing on my board now is a sample of two means. That is, we are talking about sample A and sample B. When you look at the second example too, it's talking about the group, that is group 1 and group 2. So once it is still two, once you are still talking about two sample means, you make use of t-test. But if it is more than two, you are going to make use of analysis of what? Variance. So these statistical tools is generally used to test the significance of difference. Like I told you that this is what we call test of difference. So it is usually used to test significance of difference between two sample means, and that is why we call it a t-test. So it is applicable whether the samples are small or large. If the sample is small, there is a formula to use, and if it is large, there is also a formula to use. Let's take, for instance, let us assume you are a researcher, is carrying out a research, and he has got all his data, and he want to use tools like t-test. How do you know it is t-test you want to use? Let's look at this example. For instance, I said, suppose a researcher want to study sex difference on a verbal attitude of, you know, secondary school student. Now, for instance, let's pick my own location, Ijebu-Ode, and you are picking that. Is expected to take this the two sample of the student, that is those one with male and those one with what? With female, since it is talking about gender. So that means invariably it's talking about two sample means, that is the male and the what? And the female. So if you genuinely want to look at the gender difference in their performance now, then it must be from the same school. You have to pick the same school. So the boys and the girls should be from the same school. You don't have to take it from different way, except if you are using what is it called, pre-test and post-test. We will still get to that one. There are also types of what t-test tools that we are talking about. But if otherwise, you need to do what we call, you need to make a comparison across all the level. So that means there is no meanings in what in that kind of comparison when you want to use it. So that therefore, if you look at the example that I put here now, you have to label the sample. It's either you label it sample A or sample B. That means your sample A is talking about the boys and the sample B is talking about the girls, just like in the examples of what we have it on the board. So there is a rules that we normally use, like you know, anytime you are performing a test of difference, you have to get your calculated value and then your critical value, which you normally check on the table. So for you to get the calculated value, there is a formula to use, which we can see on the board here. So we are going to get it. When we get there, we'll look at the formulas one after the other. For those that are just joining us, if you are just joining us, you can just do me good. Just put it on the comment section if you can hear me clearly. If you can hear me clearly, can you put it on the chat? Tell me you can hear me clearly. If you can hear me clearly, you can also do as well. Just put if you can hear clearly, you can just put it on that place. Let's see. Now, before we proceed, I want us to, because when you look at these two examples that I put on the board, this is talking about the independent sample t-test. And like I said, there are two types. There are two types of t-test. It's either you make use of what we call the independent sample t-test, or the other one that we call peer sample t-test, that is the non-independent test. So what are those things do you need before you can carry? Yes, thank you very much, Basirat, and thank you, Omolade. Thank you very much. So what are those things you need? The requirement for using t-test. The first thing you need is what? Is to get your data. Your data must be ready, just like the one we see on the other side here. Just like the one we see on the other side here. You need to get your data down. So the first thing is that the sample are randomly selected, unbiased. They are randomly selected, unbiased. Then the second thing is that the sample data are of interval or ratio type. And the third one is that the two populations are approximately normally distributed. So basically, there are three conditions. There are three types of what? Independent t-test. There are three types of independent t-test. The first one is when the sample, or let me say when the independent samples of unequal size and it is less than 30. If the sample size is less than 30, like if you look at all this one now, if you look at this one that I have here, you will see that the sample size here is 40 and this one is 50. Of course, that means it is more than what? It's more than 30. So the second one is that if it is lesser than 30, you make use of the first formula. I'm going to put the formula on board for all. And of course, like I always say, we don't need to feel panic because some of these formula, they are on the 4-figure table. So you can come into any examination. Most examining body within and outside the country allow us to make use of our 4-figure table, provided it did not put any external thing inside the 4-figure table. So you are free to come in with your 4-figure table, which has all this formula. So, like I said, The first one is that when you have a samples of an equal size and it is less than 30, if it is less than 30, e.g., when you have it like this now, if I have a sample size of 5 and 8, or I have a sample size that is of if I have a sample size that is equals to 10 and this one is equals to 20, that means all those ones are still less than 30. So the second one is that when the sample size are less than 30 but equal and independent. For instance, like I give the example the other time, this sample A is 5 and the sample C is what? Is 6. So the third one, so in that wise now, the degree of freedom you want to use in that place, if it is lesser, your degree of freedom will just be 2n minus what? Minus 1. That's the numbers of the size. The sample size is just 2. But I will give us an example that will talk about this. So when you have it, that'll be the sample, the degree of freedom at this point. If it is lesser than 30, that'll be 2n minus what? Minus 2. So for instance, for this now, when we get into that place, we'll look into that very well. So the other side, we also said if it is greater than 30, if the sample size is now greater than 30, there is a formula to use. And the formula to use, if it is greater than 30, when we look at this now, like I said, this one is lesser. But when we look at this one, if it is greater than what? If it is greater than 30, let's look at it. So the formula to use is that the t-test will be equals to your M1 minus M2. M1 simply means the sample size. The sample size of the first group and the sample size of the second group. Everything, you put them all together, square root, that is the variance of the first group, over the sample of the first group. Can we see that now? Then plus the variance of the second group over the sample size of the what? Of the second group. That's the formula to use if it is less than 30. So that is when it is lesser than 30. So let's see the peer sample t-test. The peer sample t-test. If it is peer sample t-test, like I said, if it is peer sample t-test, you make sure you use this formula. Like I told you, you don't need to constitute any fear because all these formulas are in our 4-figure table, which you can bring into almost all examining body allow you to bring this into the examination hall. So let's take this for instance now. Let's take this for instance. This question now is talking about, let me just read the question. I got the question for one of the past questions. It's talking about an English teacher wanted to compare the effectiveness of two methods of teaching. An English teacher wants to compare the effectiveness of two methods of teaching. Let me see if you have any. Okay, I think we still have them here. Okay, if you can still hear me, can you type yes if you can still hear me? Okay, I can still see people here. So let's take this for instance. This is an example too. I've just shown you this, an example of how an independent t-test table used to look like. When you see it like this, this is the sample size. This is the first sample, the second sample. This is the test mean. They will put the test mean here. Then the variance as well will be here. Then if it is less, you make use of this formula. So let's see this question for instance. It's talking about an English teacher wanted to compare the effectiveness of two methods of teaching reading for some Nigerian students. He deliberately selected a GSS1 boys in a secondary school in two groups. That is the group 1 and the what? And the group 2. He taught one of the group by one method and the other one by the second method. That means the group 1, he used the first method. The group 2, he used the second method. So he explained both the group at the end of the term and obtained this result as we can see here now. So that means the sample size for the first group is 40. The sample size for the second group is what? Is 50. So when they calculate the mean of their scores, he got 74 here. The means of the second one, he got 79. The variance here, he got 64. And this variance for the second group, he got 49. So now you want to use this now. Of course, you know, you will definitely set your null hypothesis and the alternative hypothesis. Don't forget, like I said, the null hypothesis is always in negative form. So when we look at this one now, I've just read the question. The null hypothesis will now be that the both method are equally. That is, the both method are equal. That is an alternative. So that means the null hypothesis will be what? The both method is not equal. So when we want to do this now, so how do you know? You need to get your calculated value before you can know the one to take, whether you are taking the null hypothesis or you are taking the alternative hypothesis. So you have to put everything into the formula. So that means the T will now be equals, the T will be equals, excuse me, okay, calculator, please, I will need a calculator. So let me, so this now, so the sample for the first one is just 40 minus 50. So 40 minus 50, everything over this S square 1, that is talking about sorry, this is the sample, the mean. Let's look at this now. The mean for the first one is just 74, and the mean for the second one is 79. So that means you take this away from this now. So let's move into this now. The square root, that is the variance. So the variance will be what? The variance for the first one is what? That's 64 over the sample size is what? Is 40 minus the variance for the first one, the second sample, that's 49 over the sample size, which is what? Which is 50. So can we divide this? Can we divide this? Can we divide this? Can we divide that? I'm looking at it. So can we divide this? I want those that are joining us to do something now. Okay, I can see your comment. Okay, I can see yes. Okay, thank you. So can we divide this? So let's work this out. Let's work this out and let's see. So let's work this out. So can I move in from here, or let me take this again? Let me take this again. Like I said, if you look at the formula, because the sample size is what? Is more than 30 now. So we have to make use of this formula. So like I said, this is your M1 and this is your what? M2. Depends on the way you want to take it. It depends on the way you want to take it. So I can decide to say what? This is my M1, the group, the first group, that's my M2, and this one can be my what? M1. Depends on the way I want to take it. So since we have it like that now, so my M1, that is the sample size. So that means my M here means my mean, the mean value. The mean value for this one is also 79. So what is the mean value for this one? So I have this as 79 minus, can we take it away from the mean of the second one? That's 74 over square root of the variance of this, variance of that one, that's 49 over 50 minus variance of the second one as well. That's 64 over 40. I hope it is clear now. Yeah. So when you look at it now, it's just like I'm taking the mean value, 79, followed by the variance of this one, that's 49, divided by the sample size, 50. Look at the second one, the mean, 74, divided by over into the square root, that is the variance is what? 64, to be divided by the sample size, which is 40. So let's put everything into the formula now. So let's find the difference between these two. So let's find the difference between the two. Don't mind, because I have to be checking if you are getting what I'm saying. If you are getting it, you can just type yes. Okay, I can see people saying yes here now. So when I take this away from this, so what is this going to become? 79 away, 74 away from 79. That's just 5. So that means I have 5 over square root. Yes, of course, just use your normal elementary mathematics here. 49. How do you want to do it? Should we find the LCM, or how do you want to do it? Just do it 49 divided by 50, and that will give you 0.98. Then 64 divided by 40, that's 1.6. So can we find the difference between that two now? So I'm giving you that one as a challenge. So can we do that? Oh, yeah, somebody is just calling my attention that this is a plus. So can we add these two together? Okay. So can we add it together now? That is 49 divided by 50. So what do you get? What do we get? So that means you got 0.98 plus 64 divided by 40. And that will give us 1.6. So can we add the two together? Plus 0.98. So what is that giving us? I want us to get that from our end. Can we get that from our end? So I want us to get that one from our end and put the answers on the chart. Put the answer on the chart. Can we get that from our end and put the answer on the chart? So let me look at that. We need to be mathematically oriented. So I'm checking it at the chart. Yes. Sir, does it mean that the larger value must come first, or M1 minus 2 must always be positive? Depends on the sample size. Depends on the sample size. Depends on the sample size. Even if I take it on the other side, yes. Who is asking the question? Yes, thank you. Aminat Aziz. So it doesn't mean, depends on the sample size. Depends on the sample size. When we look at this one now, this is group 1. But mathematically, I'm just looking at it that if you take this to the front now, you may likely get your negative. It will become a negative value. And that's why I picked the biggest value to be at the front. Depends on the way you arrange it, since you are looking for the calculated value. So let's look at this now. I think I've tried to explain that. So when we look at this now, so this will be 5 over. So if I added this now, 0.98 plus 1.6. Yes, that will give me 2 points. So let me just manage to use this place. My t is equals to this. So let me manage to use this place. That is 5 over square root of 2.58. I have to manage that place, okay, over that. So when you square root of 2.58, yes, that is going to give me 1.601. That means to 3. Okay, let me take it. That's 1.61. I'm taking that to 2 decimal place. So at this point now, if I divide this one now, so that will be 5 divided by 1.61, and that will give me 3.11, because I'm going to have 3.105. So if I take it to 2 decimal places, that will be what? 3.11. So that means my calculated what? My calculated value is what? Is 3.11. If you get 3.11 from your end, can you type yes on the chart? Yes, thank you. Basirat is asking me, you didn't square the variance. I can't square the variance here, because this variance here, don't forget that the formula for variance is this. So that means I'm talking about S, the variance, that is S squared. That is the symbol for variance. It's not that I'm going to square it. I'm not squaring it. I'm not squaring it. Please, if that is clear, can you type yes? That's the essence of having a live class. It's not a recorded video. If that is correct, can you, Basirat, if you get that, Basirat, if you get it, can you type yes? If you get what I've just said here, you didn't need to square the variance. The formula didn't say we should square. It's just talking about the variance over sample. I'm waiting for Basirat to talk now. If it is clear. If it is clear, Basirat, if it is clear to you, can you type yes? Okay, maybe she's not there again. But what I'm trying to say is that instead of you you don't need to square this, because this simply means, this S square simply means variance. Variance of the first group, variance of the second group, sample of the first group, sample of the second group, mean of the first group, mean of the second group. I hope that is taken now. So once you get your calculated value, I've got my calculated value as 3.11. So the next thing now is for me to go and look for my degree of freedom. I have to go and look for my degree of freedom. And don't forget that in this place, the degree of freedom I'm going to use here now, because this sample size is more than 30. So my degree of freedom is not going to be 2n minus 1. It will be the sample, the first sample plus what? Plus the second one, that's plus 2. Yes, I think I'm right. Yes. So the degree of freedom, let me take that again, because you are going to use your degree of freedom to check the, you are going to use your degree of freedom to check the calculated word, to check the critical value, that is the table value. That is the data you want to go and check on your table. So if I'm to use that now, that means my degree of freedom, because the sample size is more than 30. So that the degree of freedom will be the sample size 1 plus the sample size 2 minus 2. So the sample size 1 is what? Is 40 plus 50. This is the sample size minus 2. So 40 plus 50, that will be what? That will give me 90 minus 2. And that will give me what? That will give me 88. So that means I'm going to my table now to check my degree of freedom on 0.01. I can check it under 0.01 and 0.08 under 88. So I will need to bring out my 4-figure table now. I will need to bring out my 4-figure table. So if I bring out my 4-figure table, where am I going? Unlike the chi-square, where you have to go to your chi-square table. So for the t-test, you also need to go to your t-test table. So I'm going to open that now. So where will I see my t-test table? Where will I see that? Can somebody just point that out for me? Where will I see that? On the chart. On the chart, where will I get my critical table? Which table am I checking now? I need someone to talk to me. Which table am I checking? Don't forget, yesterday when we did that of chi-square, we checked chi-square table. So this time around, which table am I checking? So that you will not just hold your table and you'll be asking your colleagues, which table am I checking here? Or help me to look at it too, so that you have confidence in the table you want to check. I need a response on the chart. Which table am I check? Which table am I going to check? Which table am I going to check? Okay. Because of our time, so I will go and look for my 4-figure table. I want to bring it out here. For those of you that can see, I'm going to check the T distribution table. Can you see the T distribution table? So I'm going to check the T distribution table. So I'm checking the T distribution table now. under 88. So if I check under 88, 0.01 under 88, what is that going to give me? What is that going to give me? You will see that you may likely not see 88, but anything we can see 60 here. So that means you are picking your word 60, because after 60 is 120, so you are picking 1.29. So you are picking 1.29. So under 0.01. So I've gone to the table now. Under 0.01, so I pick 1.29. I'm checking it under 88. So 0.05. 0.05. You do the same thing. You remember they were talking about under the T distribution table, the alpha level of significance for direction. There is a one tail, there is a two tail. So you know how to check that. I've explained that in that of chi-square video. So when you check that one now, under 0.05, 0.05, you will get 1.67. 1.67. Now, I've got my critical value, which is table value. This is my table value, and this is my calculated value. So my calculated value is 3.11, and my table value is what? 1.29 at 0.01 and 1.67 at 0.06. Now, when you compare these two together, can we compare these two together? So what's the difference between them? So which one am I taking? I've told you that yesterday. Am I taking the non-hypothesis or the alternative hypothesis now? I want a response in the chat. Which one am I taking? Non-hypothesis or alternative hypothesis? Because my calculated value now is bigger than the table value. So which one am I taking? Let's go because of our time. Which one am I taking? Which one am I taking? Which one are we taking? I need a response in the chat. I need a response in the chat. Which one am I taking? Alternative hypothesis. Yes, thank you. Omalade, thank you. I'm taking alternative hypothesis. Why am I taking alternative hypothesis? Because the calculated value is more. The calculated value is more. The calculated value is more than the table value. When you look at it now, 3.11 is greater than 1.29, is even greater than 1.67. So I'm going to take my alternative. I'm going to take my alternative hypothesis. So which says, what did the alternative hypothesis says? Because I have put it down before. So when we look at it now, we can now conclude that what the level of, so since the this is greater, since the calculated value is greater than the table value, then we take the alternative hypothesis, which says the applied group is effectively more than what? More than the group one. That was what we said for the non. So because the non-hypothesis is a negative, so we have to take the positive one. Is. So don't forget, the first one will say there is no significant difference. That's the non-hypothesis. The alternative will say there is. So that means this time around now, we say that what? There is. When you look at it again, if you listen to this video again, you see that when I stated the non-hypothesis, the non-hypothesis say that both methods are equally effective. That's the non-hypothesis. So the alternative now one would now be that what? That means the group 2 is highly effective than that of the word, the applied one. That means there is effective between the two. So with this now, we have come to the end of the first example here, which is talking about we have come to the conclusion with the first example, which is talking about the peer sample t-test, the peer sample t-test. So I'm going to do a kind of a recap on this. The peer sample t-test have give us a condition, and the condition is that when it is what? When it is more than 30, you use this. If it is lesser than 30, you use the other formula, which I've stated earlier on this. If you watch the video, you will see it there. And I also do it well if I can attach picture under this video so that you see all the sample. Like I said, there is no need to panic. You can check your 4-figure table for all the formulas and whatever things you need. So now let's move to the peer sample t-test now. Let's move on to the peer sample t-test that is lesser. You can see that this one is, the group size is more than 30. Let's look at those one that is lesser, especially in terms of pre and post test, which we have here. So if this is clear, can we have a comment on the chat? Can we have a comment on the chat? Can we have a comment on the chat while I move on with the second one? It may take time. Okay, alternative, I've got that. So I want to focus on this one very well for us. It may look tiny, but because the sample size, we want to look at, okay, it is clear. Thank you, Omolade. Now, let's look at this one now. This second one is talking about a researcher, a teacher or a researcher who has taken a survey in changing the attitudes of a student. He has tried to take a survey in the change of the attitude of a student to a modern mathematics. And it's like looking at the beginnings of the term, he administered, like I said, this is an experimental study. Someone is trying to experiment an approach that he called the modern mathematics of his modern mathematics student. So that means he has taken this sample before he applied the treatment. It's just like before we started this class now, I could have give you this kind of a question and I asked you to solve it. You know, I've not taught you anything. I've not teach anything on t-test. And I give you questions on t-test. Of course, your performance under that may be somehow low if you don't have a prerequisite knowledge on it. So after doing that, I will keep the test aside. And that is exactly what the teacher did. And the test that he has done before he applied the treatment is what we call pre-test. Now, after applying the treatment now, he will conduct another test that he called post-test. Now, when you look at the sample size for this, is 1 to 26. That means it is lesser than what? It's lesser than 30. And they said, if it is lesser than 30, what formula are we using? So I'm going to put the formula here now. Which formula are we using? If it is lesser, C equals the difference over square root of the sample summation D square minus summation D all square, everything over the sample size square into n minus what? Minus 1. That is the formula if it is lesser. If it is lesser. So here now, where the D bar is the absolute difference of mean of the first group and the second group. So where this D bar here, the D bar that we see here is talking about the mean of the pre-test minus mean of the what? Of the post-test. You know, the pre-test is 1. The mean of the pre-test and the mean of the what? Of the post-test. Of course, we definitely get that one here. So what other things do we have there? So we got from there now, we now have what? The D itself. That is, we are looking at it. Now you see summation D. So what does that D mean? The D means the difference between the pre-test and the what? And the post-test. So this one, this D here, is talking about the difference between the mean. The difference between the mean of this sample. That is, you have to find the mean of the pre-test and the mean of the post-test. And when you look for the difference between these two, that is where you get your D bar. That is the mean of the what? Of the pre-test minus mean of the what? Of the post-test. Or we say the absolute difference of the what? Of the mean. So is that taken now? So let's move on to the first one now. So while explaining that, I want all of us to add everything here. I'll be calling the figure one after the other. If it is not, I know it will definitely be clear because I'm going to share the picture under this video. So you are going to add everything you have here together and divide it by the sample size, which is what? 26. And whatever things you get is going to serve as your what? As your mean for this pre-test. So the same thing you get here will serve as your mean for the what? For the post-test. The comparison between the two now is what is giving you your what? Your D bar. So let's move on now. So the D itself, the D you are seeing here, is talking about the difference between the pre-test and the post-test. Okay, so then of course this square is just for you to square the values of D here. Then what else again? Then you look for the summation D square here and put everything into the formula. So let's move into the formula now. If the formula is clear, can we type yes? And if it is not clear, I can take that again. If the formula is clear. If the formula is clear, can we take that again? So like I said, I will explain the formula again. Like I said, you don't need to cram anything because you have the formula inside the four-figure table. So this D bar here, it simply means the mean of the pre-test, the mean of the first group. Don't let me use because it could be group in your own case. The mean of the first group minus mean of the second group. So that means you have to get your mean here. So when we calculate this now, I've done the calculation and I want you to just confirm it after I finish this video. Just confirm this. So the mean of this one is equals 31.72. That's the mean. That is when you add everything here and you divide it by 26, you get 31.72. So that is your word. That's the. So the mean of the second group. The mean of the second group, which is the post-test here, that's 35.12. That's 35.12. That is after you add everything here and you divide it by the sample, which is 26. So I got 35.13. So I've got that. So since I've got that now, so the next thing for me to do now is to find the difference between the pre-test and the post-test. That is the difference between the group. So 44 minus 46, that will give me minus 2. 24 minus 29, that will give me minus 5. 29 minus 32, that will give me minus 3. 39 minus 36, of course, that will give me 3. This minus this, that will give me 4. This minus this, that will give me minus 5. This minus this, that will give me 0. This minus this, that will give me 4. 17 minus 25, that will give me 17 minus 25. Yes, that will give me 8. 23 minus 28, that will give me minus 5. 36 minus 40, that will give me 4. 29 minus 39, that will give me minus 10. 47 minus 46, that will give me 1. 37 minus 42, 43. Yes, that will give me minus 6. And the same thing like that. So you get your difference. That is the difference between the first group and the second group. Then thereafter, you move on and get your d square. Of course, your d square is just square of this difference. So that is square of minus 2 is 4. Square of minus 5 is 25. Square of minus 3 is 9. Square of 3 is 9. Square of 4 is 16. Square of 5 is 25. Square of 0 is 0. Square of 4 is 16. Square of 8 is 64. Square of minus 5 is 25. Square of 4 is 16. Square of 10 is 100. Square of 1 is 1. Square of minus 6 is what? Is 36. You now add everything together. If you get this clearly, I'm going to record this number again. Let me record this number in case if it is not clear. For the pretest, 44, 24, 29, 39, 45, 24, 29, 40, 17, 23, 36, 29, 47, 37, 34, 39, 14, 21, 33, 41, 30, 11, 39, 41, 31, 28. For the post-test, 46, 29, 32, 36, 41, 29, 29, 36, 25, 25, 40, 39, 46, 43, 44, 32, 18, 26, 31, 45, 40, 28, 40, 36, 38, 36. So what you just have to do here is to add everything together and divide it by 26, and that will give you the mean of the post-test. Add everything together here, divide it by 26, that will give you the mean of the what? Of the pre-test. So, and at this junction now, you have to get your d square. So the values of our d square now, what is the values of our d square? When you come here now, the values of our d square is 1084. 1084. 1084. And the values of our d here, when you add everything together here, that will give me 88. That will give me 88. So is that clear now? So I can now come back to the formula. So what did the formula say? The formula said the t-test, the calculated value, which is t-test, is equals to, that is the d bar. So the d bar simply means the mean of the first group minus the mean of the second group. So when we find the difference between that, so that will give me the mean of the first group. So that means t-test is equals to 31.72 minus 35.12 minus 12. So, and what is that going to give us? The difference between the two, that's an absolute value. Don't forget that it's an absolute value. So everything over square of n, our n is 26, multiplied by summation d square, that is 1084 minus, I know some of you are saying the formula look like that formula of Pearson. It look like formula of Pearson correlation. It look like, so but it's not. So summation d. So summation d is 88. That is addition of all the difference between the pre-test, addition of all the difference between the two group, 88 all square, everything over the sample is 26 square into 26 minus what? Minus 1. So let's put all this together. Let's put all this together now. Take your calculator and put it together. So the difference between the two, so that is 31.72 minus 35.12. So that will give me 3.4. I know you will say minus 3.4, but don't forget that the formula says it is what? It is the absolute difference. Absolute. And when we say something is absolute, if it is negative, absolute value make it negative becomes a what? A positive. So that's why it's becoming 34. So everything over. So here now, 26 multiplied by 1084. That is giving me 28,184 minus 88 square. 88 square is giving me 7,744. Everything to be divided by here, don't forget, 26 square. That will give me 676. And don't forget, just take one away from this. That will give me 20 what? 25. So from here now, let me clean this place so that we get more space at this point. So this is going to give me 33.4 over square root. The difference between these two, 28,184 minus 7,744. And that will give me 20,440 over, this is just 676 multiplied by 25. And that will give me 16,900. So I'm going to take 33.4 over 20,440 divided by 16,900. And that will give me a square root of 1.209. So if I square, this is 3.4. If I find square root of 1.209, that will give me square of 1.209. Yes, that will give me 1.099. Is that correct? That will give me 1.099. So let's add that. I'm going to take that again. That's 20,440 divided by 16,000 plus 16,900. Yes, that will give me 1.21. That will give me 1.21. Is that what? Yes, that will give me 1.21. So 1.21 now, when I take square of that, so let's take square of that. Okay, of course, I can take this one approximately to, since this is 3 point what? So at this junction now, this one is equals 3.4 over 1 point, approximately to 1.1. So approximately to 1.1. So that is 3.4 divided by 1.1. And that will give me 3.09. That will give me 3.09. That will give me 3.09. So my calculated value now is 3.09. 3.09. I know it's a long process. It's a long process, but you just have to take it like that. You just have to take it like that. Just follow the step. If you follow the step one after the other, you will definitely get the final answer. But if you don't follow the steps one after the other, you may likely mix it up. So at this point now, the only thing that we are left with now is to get our degree of freedom. And I've given us the formula for degree of freedom. The one that is lesser than 30, we said it is the first sample plus the second sample minus 2. So, but for the case of this one that is greater than that is greater than 30. You can see that this one is lesser than 30. The one we use, if it is greater than 30, the degree of freedom will be sample 1 plus sample 2 minus what? Minus 2. But if it is lesser, that will be n minus what? Minus 1. So that means for the case of this one now, it's going to be 26 minus what? Minus 1. So that means your degree of freedom is just 25. So that means you are checking whatever you want to check under the 4-figure table under 25. So you bring out your 4-figure table again. Once again, don't forget, where are we checking this? Under what are we checking t-test? Can I have it? Those that are following us, can I have it on the chart? Which table are we using? Under which table are we using to check? Are we using to check t-test? The critical value, the table value. The table value. Can I have a response in the chat? So you are checking it under T distribution. T distribution. So I'm going to show us T distribution. Can we see T distribution under the 4-figure table? Yes, the table distribution. So that is the T distribution. Can we? Thank you, Omolade. So if you are checking that now, you are checking 0.01 under 25. So where are we seeing that under 25? Can we see under 25? For those that are checking it, can we see under 25? So what do you get when you check it under 25? 0.01 under 25. What do you get? I want us to see that as 1.17. Can we see the 1.17? Can we see that? Yes, I'm trying to bring it. Can we see it? So that is 1.17. So under 0.001, 0.0125. Can we see that? It's giving us 2.49. So that means from the table now, under 0.05, under 0.01, under 0.05, we got 1.71. Under 0.01, we got 2.49. Now compare these two together with the calculated value. Compare the two together. Which of the hypotheses are we taking now? By comparing the table value and then the critical value, which of these are we taking now? Null hypothesis or alternative hypothesis? Which one are we taking? Null hypothesis? I want a reaction in the comments. I want a reaction in the comments. Alternative. Thank you, Omolade. Omolade said we are taking alternative. Why are we taking alternative? Why are we taking alternative? You have to tell me. You can't just say we are taking alternative. Don't forget the formula is still on the board. If the calculated value is lesser than the table value, you take null hypothesis. But if the calculated value is more than the table value, you take the alternative. So which one are we taking now? Which one are we taking now? So we can now say Yes, no, that's not what I'm asking. No, Omalade have got the answer. She has got the answer. Omalade has got the answer where she said we are going to take the alternative. And the reason why we are taking alternative is because, yes, we are taking alternative hypothesis because the calculated value is greater than the t value, that is the table value. So therefore, we will set aside the null hypothesis and take the alternative hypothesis. I think with this, we have been able to take a deep look into t-tests. I'll just do a kind of a recap or a review of t-tests. That basically there are two types of t-tests. Basically, there are two types of t-tests: the independent sample t-test and the other one, which we call peer sample t-test. The independent sample t-test, like I said, basically there are three formulas. The first formula is that when the value is lesser than 30, when the sample is lesser than 30, there is a formula to use. When the sample is greater than 30, there is a formula to use. If you look into the video, thank you, Basirat. Thank you, Basirat. Said 3.725. Okay, that's what you got. Well, it's still almost it's very close. So if it is a peer sample, like I've said, a peer sample is what I've just shown you, that will have two group, and that is an example that we have here. So I will try to put a questions under this video in case if you want to practice both the independent sample t-test and then the peer sample t-test. You will get a questions under this. So we have come to the end of this class. If you have any question, I will be waiting for the next 5 minutes. Drop your questions here and let me attend to your question under the comment section. Question, you can drop your questions. So time for questions. So drop your questions. Yes, Basirat, I've seen the alternative. Yes. Can we drop our questions? We have come to the end of the class. But in case if you have any question, you can drop your question under the comment section. In case if you have any question, you can drop your questions under the comment section. Don't forget, basically there are two types of t-tests. The independent sample t-test and the peer sample t-test, which is a non-independent t-test. And like I said, a t-test is a statistical test that we normally use to test significance of difference between two samples. We normally use to test, yes. Because the t calculated is greater than the t table, we are taking alternative. Thank you, Olaniyan. Thank you, Olaniyan. You are right. Any question? Any question? Any question? So I'll just run you through again. I can say the other name for t-test is test for two sample means. Test for two sample means. And t-test is basically a statistical test that we normally use to test significance of difference between two samples. So, ladies and gentlemen, dear colleagues, dear participants, dear students, we have come to the end of t-test. If you check under this video, you will see question, practice question. I'm going to put a link under this that can take you to where you can see alternative questions. You can see more questions you can use to practice on t-test. If you find this class interesting, you can try to subscribe to this channel. If you are joining for the first time, try to go to share, copy the link to the video, and share with other students or other researchers that need statistical, that need a t-test to do a kind of a statistical t-test of 2 sample means. Thank you and God bless you all. Bye for now.